Look at this split-screen diagram. On the left side, we see the immediate result of peak fruit season in Uganda. When crops like pineapples and mangoes ripen simultaneously, local supply outpaces demand. Prices collapse, and tons of highly perishable food simply sit and rot. The right side of the model shows the economic alternative. By processing those perishable raw materials into shelf-stable goods, farmers bypass the immediate market glut. They can safely store their harvest and delay selling until local supply drops and market prices recover. The reason fresh fruit spoils so rapidly comes down to biology. Fruits are dense with water and nutrients, which creates an optimal breeding ground for spoilage-causing microorganisms like bacteria, mold, and yeast to rapidly multiply. This diagram maps out the core science of value addition. To preserve the harvest, we have to interrupt that biological decay. We halt microbial growth through 3 distinct, measurable interventions: removing the water, applying high heat, or chemically binding the moisture. Let's start with dehydration. As heat is applied to a fresh pineapple slice, internal water evaporates out, extending lifespan and drastically reducing weight. By dropping moisture below a specific threshold, spoilage microbes cannot survive. To maintain this, secure the fruit inside a moisture-proof plastic pouch. When lowering transportation costs over rough rural roads, drying is the most effective choice. It eliminates heavy water weight and secures the harvest for long-term, stable storage. Our second pathway extracts liquid for ready-to-drink products, then immediately pasteurizes it. This intense high-temperature burst acts as a thermal defense, instantly destroying active microorganisms in the raw liquid. Because it remains vulnerable, the sterile juice must flow directly into an airtight, sterile bottle. Extracting and pasteurizing juice turns a cheap raw material into a premium convenience product. However, the product's lifespan depends entirely on perfectly maintaining the airtight thermal barrier through proper packaging. The third technique, jam making, relies on sugar as an aggressive chemical preservative. Boiled sugar molecules physically lock on to water molecules. Spoilage microbes cannot access the water and effectively starve. To protect this delicate chemical matrix, the jam is enclosed inside sealed glass jars. By utilizing this water-binding technique, producers take thousands of surplus seasonal fruits that would otherwise rot and convert them into high-value luxury items that urban supermarkets demand. None of these preservation techniques work if the raw material is compromised. Look at this sorting line. Overripe or bruised mangoes already carry microbial infections. Processing cannot reverse rot. Those fruits must be discarded, ensuring only perfectly ripe fruit enters the sterile processing line. Let's test this. Imagine a farmer in Luero facing a bumper mango harvest. Her primary goal is to drastically reduce the physical weight of her crop for cheaper transport into Kampala. Which processing method and packaging should she choose? The correct approach is dehydration. By drying the mango slices, she eliminates the heavy water weight, and by sealing them in a moisture-proof plastic pouch, she prevents them from rehydrating during transport. Choosing the correct method is only part of the equation. Strict raw material selection, fully sanitized equipment, and precise packaging choices form the non-negotiable foundations of any successful agricultural preservation. This matrix summarizes everything we've covered, mapping the agricultural goal directly to the scientific mechanism. If the goal is weight reduction, the technique is drying to remove moisture, packaged in a moisture-proof pouch. If the goal is flavor appeal, you pasteurize juice to destroy microbes, sealed in airtight bottles. And for long-term storage, jam binds water with sugar inside glass jars. Memorizing these exact connections between goals, biological pathways, and required packaging is precisely what you need to master your UNAB exams and safely apply these concepts in the field. By learning how to precisely control water, heat, and sugar, agricultural producers stop being vulnerable suppliers of raw materials. They take control of their harvest and transform themselves into highly profitable, resilient consumer goods brands.